So we are considering this is the video lecture, second video lecture for transfer function. We are considering a little more complicated example. Here you see there are two masses, mass 1 and mass 2. In the question it is asked, you find the transfer function x2s by f of s. I could have asked you x1s by f of s also. So when I am asking you x2s by f of s, the output is x2 and input is f of t. So I hope you recall there are 4 steps. Step 1 is identify the input and output. Step 2, write the differential equations for the system. Step 3, take Laplace transform. Step 4, rearrange terms. Let us do it. So for these complicated examples, there's something called free body diagram where we'll mark all the forces. So let us look at the free body diagram. Here, for the free body diagram for mass m2, there's a force F acting in this direction. As I told you earlier, for the spring, this end of the spring is moving. The displacement of this end of the spring is x2 and displacement of this end of the spring is x1. So let us assume x2 is greater than x1. So I'm trying to expand the spring, so spring will contract. So the force at this end will be K2 into x2 minus x1. Similarly, the force at this end will be equal to K2 into x2 minus x1 in this direction. Similarly, for the dashpot, it will be V2 into x2 dot minus x1 dot. And for mass, only one end is there. Like mass is a rigid body. Every part of the mass will move by the same amount. That is, so the acceleration will be m2 into x2 double dot. So this is the free body diagram for the mass m2. Free body diagram for second mass is m1 is easy because we know these two forces. The opposing force will be because of this spring. This end is fixed. This line shows that this end is fixed. K1 into x1, m1 into x1 double dot and b1 into x1 dot. So I will get one equation. Let me take a pen. So I'll get one equation for where's the I'll get one equation for this mass, which is F is equal to m2 x2 double dot plus k2 x2 minus x1 plus b2 into x2 dot minus x1 dot. Similarly, I'll get a set of one equation for mass m1. Let us go to the next slide. So recall, first step is input and output. We know input is f of t, output is x2 of t. Second step is differential equations. And third step is Laplace transform. We'll do these three steps in this slide. So this is the diagram which I have shown earlier. F of t is m2 for this mass m2. I have this force k2 into x2 minus x1, m2 x2 double dot and b2 x2 dot minus x1 dot. Let us see the equation. F of t is m2 x2 double dot plus b2 into x2 dot minus x1 dot plus k2 into x2 minus x1. So we got one equation. Next, let us look at this mass. For mass m1, let us look at the equation. What is the equation? K2 into this force, K2 into x2 minus x1 plus these two forces are acting in this direction, b2 into x2 dot minus x1 dot. This is equal to what? m1 x1 double dot plus b1 x1 dot plus k1 x1. So corresponding to mass m1, the equations are here. I'll repeat again. K2 into x2 minus x1 is equal plus b2 into x2 dot minus x1 dot is equal to m1 into x1 double dot plus b1 x1 dot plus k1 x1. What is step 3? Take Laplace transform. We'll assume Laplace transform of f of t is f of s. Laplace transform of x of t is x of s. So Laplace transform of x dot will be s x of s. Laplace transform of x double dot will be s square x of s. So let us do one by one. So let me change to pointer, eraser pointer. So Laplace transform of f of t will be f of s. Laplace transform of m2 x2 double dot will be m2 s square x to s. Laplace transform of b2 into x2 dot minus x1 dot will be b2 into s x to s minus s x1s. And Laplace transform of k2 into x2 minus x1 will be k2 into x2s minus x1s. Similarly, I'll take Laplace transform of this. Don't look here. Laplace transform of x2t will be x2 of s. I take it Laplace transform of this term first. Laplace transform of b2 into x2 dot minus x1 dot. That is b2 into s x2s minus s x1s plus k2 into x2s minus x1s equal to b1 into b1 x1 dot. Laplace transform is b1 s x1s, and Laplace transform of k1 x1 is k1 x1s. m1 x1 double dot is m1 s square x1s. So let us go to the next slide. Rearrange the terms. So let me go to the previous slide. So here we want x2s by f of s. So in these two equations, m2, b2, k2, k1, b1, etc. are given. x1, x2 are something which we introduced, and f is the output. So we want a relationship between x2 and f. So what should I do? I'll pause for a while. You think, what should I do? I should eliminate x1. I don't want x1. So let us go. So this you should do cleverly. So these are the equations which I wrote from the previous slide. So what I will do is, I have taken everything on one side. Okay. This is f of s equal to this equation is same as this equation. What have I done? I have grouped all x1 and x2 together. Here I'll take pen again. Here let us look at the x2 terms. There's an x2 term here, m2s square. So I wrote here m2s square. Then there's an x2 term here, sx2, and there's a b2 here. So I'll get b2 sx2. And there's another x2 term here. So I got a k2 here. So there are three x2 terms. What am I doing here? I'm collecting all x2 terms and collecting all x1 terms. Let us look at x1 term. There's a minus s x1. There's a b here. So minus s b x1. So minus s b. What is the subscript? b2. So minus b2s. And there is a minus x1 and k2. So minus k2 x1s. So this is just a rearrangement of terms. I know that all of you are good at this. Similarly, I'll rearrange the terms. I'll get all the x1 terms. What are the x1 terms? I'll underline the x1 terms. b2s, then k2, b2s, k2, then what? I want x2 terms, isn't it? b2s and k2. Only two terms are there, x2. And all the remaining terms are x1. So there is a b2s x1 minus, so you could look into this. So now what should I do? I want to eliminate x1. So if you look at this equation, it's connecting x1 and x2. So I don't want x1. So from this equation, I can get an expression for x1 in terms of x2. So x1 is, I kept, I brought this on the other side. So this entire term, will go into the denominator. So x2 is b2s plus k2 divided by m1s square plus b1s plus b2s plus k1 plus k2. So you are almost done. What is the next step? Can anybody tell? You think here there is x2 and x1. I want to retain x2. So I will substitute for this x1. So I'll put this x1 here. So I'll get f of s is equal to m2s square plus m2s square plus b2s plus k2 plus k2 into x2s minus b2s plus k2. Instead of x1s, I'll substitute this. That is there in the next slide. So m2s square, this term is as it is. Let me take the pointer, the laser pointer. Let me take the laser pointer. So this term will come as it is. M2s square, because it is x2. M2s square, that has come as it is. B2s plus K2 is here. And instead of x1s, what will I do? I'll have this term. So we are almost done. So I got x2 and f. What do I want? I want x2s by f of s. I want x2s by f of s. So this is f of s is equal to something into x2s. So next slide we'll get the answer. So thank you very much. So finally we are done.